Hi everyone. Today we'll discuss about the methods of preparation of hydrogen peroxide. In last session, we have discussed about the valence strength of hydrogen peroxide. Okay. First method of preparation is the here name I'm giving. It is Merck's method. Merck's method. In this Merck's method, we have to take cold 20% cold sulfuric acid, ice cold conditions you have considered. So 20% ice cold sulfuric acid when treated with sodium peroxide or hydrated barium peroxide. We get hydrogen peroxide. Hydrogen peroxide is obtained by using this remedy. H2O2 is obtained. H2O2 is obtained by treating 20% ice cold sulfuric acid dilute sulfuric acid with sodium peroxide or hydrated barium peroxide. H2O is obtained by treating 20% ice cold sulfuric acid with sodium peroxide or barium peroxide. See, here remedy reactions Na2O2. This is sodium peroxide with H2SO4. H2SO4 is 20% ice cold condition. Here you can easily write the reaction. 2 sodiums with SO4 eliminates as sodium sulfate. This is byproduct here plus 2 oxygens and 2 hydrogens combined with each other and forms hydrogen peroxide. This is our product. Here almost 30% we get. Similarly, barium peroxide. This reaction is important. Barium peroxide 8H2. This is hydrated barium peroxide. It also when treated with sulfuric acid H2SO4, same thing, 20% ice cold condition. So here again, here 2 oxygens with 2 hydrogens of sulfuric acid produces H2O2 is our compound, and along with this we get barium sulfate. This is precipitation. Here sodium sulfate which is formed at first reaction is not precipitation, but here barium sulfate is precipitation. 8 water molecules separated. Here only 5% hydrogen peroxide we can get. Here important thing is why we should take hydrated barium peroxide. Here we are not taking any hydrated form. Here we are taking hydrated barium peroxide. What is the reason? So here reason behind this is here after some reaction we will get here barium peroxide, barium sulfate which is precipitation, and after some time some barium peroxide is unreacted which is present in the reaction mixture. Here the formed barium sulfate forms a thin layer above barium peroxide which is unreacted, so that that layer which is formed can prevent further reaction, so that hydrogen peroxide formation is very less. The yield of hydrogen peroxide will be less. So here reason I am writing here formed barium sulfate precipitation. The formed barium sulfate PPT can form a protective layer on unreacted barium peroxide. If it is not in hydrated form, it is not in hydrated form. It is not a hydrated form. So that further reaction can be prevented. What happens when further reaction prevented? Further reaction is prevented means H2O2 which we are preparing here is with lesser amounts we can get. So less amount of hydrogen peroxide we can get. If we take dehydrated, otherwise unhydrated barium peroxide. If we take hydrated form, we can get only 5%. If we take unhydrated form, it is less than that. So examination point of view, this is important. Okay. Similarly, we can prepare in the same way. Barium peroxide paste when passed through carbon dioxide. Otherwise, carbon dioxide gas is passed through barium peroxide paste. Otherwise, barium peroxide will be treated with phosphoric acid. Also, we can get hydrogen peroxide. Hydrogen peroxide is obtained by passage of carbon dioxide gas through a paste, moist barium peroxide. Otherwise, phosphoric acid when treated with moist barium peroxide also produces hydrogen peroxide. So those reactions are made here. These two reactions are comes under Meltz method. This one. Then next reaction I am writing here. Passage of carbon dioxide gas through barium peroxide paste. Paste means we have to add some water. So water, carbon dioxide, barium peroxide. So these three reactions are there. From barium peroxide, oxygen molecule, oxygen, and from water, H2 forms H2O2, hydrogen peroxide. Plus, what is the remaining? If you take this oxygen here, it becomes CO3. This CO3 combines with the remaining barium and forms a barium carbonate precipitation. This is one reaction. Similarly, we have one more reaction when barium peroxide treated with the phosphoric acid H3PO4 also produces H2O2 hydrogen peroxide. Then we can get barium phosphate. Barium phosphate formula you should know. How you can write barium phosphate formula? Barium charge +2 and phosphate ion charge -3. So combining capacities 3 for phosphate and barium 2. So if you write, if you take this graphs, you can get barium phosphate formula. These three you have to write below barium, 2 you have to write below phosphate. So that Ba3PO4 taken 5 we can write. So here you can observe 3 moles of barium are there, or 3 barium are there, 2 phosphates are there. So here only one phosphorus is present, so I am writing here 2 to balance this phosphorus. Similarly, to balance barium, here I am taking 3. So this is the balanced equation. Here how many hydrogen peroxide we can expect? 2 into 3, 6 hydrogens are there. So that here we can write 3H2O2. So these are the methods of preparations of hydrogen peroxide. Then we have 2 more methods which are very important. One is electrolytic method of preparation of hydrogen peroxide. Electrolysis. Here, electrolysis means we should take a container. In that container, in that vessel, we should add some electrolyte. We should keep 2 electrodes, anode and cathode. Then after, when through anode and cathode, when acid is passed through the solution, first the solution is dissociated into cation and anion. Cations are migrated towards negative charged electrode, that is cathode. Anions are migrated towards positive charged electrode, that is anode. So like that at anode and cathode, respective ions are discharged to give respective compounds. So here electrolytic method we will discuss now. Electrolysis of 50% H2SO we should do. Here the important method. Here electrolysis of 50% H2SO4 by electrolysis of 50% H2SO4 produces hydrogen peroxide. So in this electrolysis process, why you should take 50%? Why not less than 50% or 40%? 50% means this is the concentrated solution. 50% means what? This is concentrated solution. So in electrolysis process, we have concentration effect also. less than 50% or 40% or 38% or less than that 20% if you take, that is nothing but dilute solution. See here, just brief explanation give now related to electrochemistry. So what happens when H2SO4 is dilute? H2SO4 when undergoes electrolysis, but it is dilute. It is dilute. That means the water concentration will be more here. Then H plus ions can produce, and along with that SO4 minus 2 ions are produced. Otherwise H plus ions and HSO4 minus ions are produced. And dilute means water quantity is more, so that water also present here, that water also dissociated into H plus ions and OH minus ions. So at cathode, here positive ions are moved towards cathode, negative charge electrode. There is no any competition here. All are H plus ions only. H plus ions are produced by H2SO4 and the same H plus ions are formed by water molecules also. So that here H plus ions undergo reduction and produces hydrogen gas. Hydrogen gas is liberated. Then among OH minus ions and SO4 minus 2 ions, if you take discharge potential, otherwise the energy required to discharge SO4 minus 2 ion is more compared to OH minus ion. So that SO4 minus 2 ions remains in the solution and OH minus ions are participated in the discharge process. So at anode, what reaction takes place here? OH minus ions. Here I am taking 4 OH minus ions. 4 OH minus ions loses 4 electrons and produces here 2 water molecules, along with this oxygen gas is liberated. So these are the electrode products when dilute H2SO4 is electrolyzed. Dilute H2SO4 is electrolyzed. When dilute H2SO4 is electrolyzed, electrode products are hydrogen gas and oxygen gas. At cathode, hydrogen gas is liberated. At anode, oxygen gas is liberated. Then here I am giving explanation with respect to concentrated H2SO4. H2SO4, it is 50%, more than 50%, otherwise here concentrated I am writing. When it dissociated, it produces H plus ions and SO4 minus 2 ions. Here concentrated means quantity of water is less. So water is not participating in ionization, otherwise dissociation like dilute H2SO4 electrolysis. So here only these two are produced. So at cathode, what reaction we can expect at cathode? 2 H plus ions accept 2 electrons and produces H2 gas. But here in this way water is not dissociated. Here OH minus ions are not present, so that only SO4 minus 2 ions are participated in the reaction. When SO4 minus 2 ions are participated, here I am taking 2 SO4 minus 2. So you can produce S2O8 minus 2. S2O8 minus 2. It is per sulfate ion by losing how many electrons? Here total 2 into 2, 4 negative charges are there. Here 2 negative charges, there 2 negative. 2 electrons you can release. That is per sulfate ion. Otherwise, sometimes you may expect a lysis reaction also. H2SO4 dissociate to give H plus ion plus HSO4 minus ion also. As per the requirement, we can take. Here at cathode, same thing. 2 H plus ions now accept 2 electrons and forms the hydrogen gas. At anode, HSO4 minus 2 moles I am taking. Here it loses 2 electrons and produces here H2 S2O8, which is peroxide sulfuric acid or per disulfuric acid, which is called as Marshall's acid. So this is the difference. Why we are taking 50% H2SO4. This concept is there in electrochemistry part. This concept is there in electrochemistry part. In second year, you can read. If it is long-term students or second year students, they can understand easily. Only for first year students, it is somewhat difficult to understand. In electrochemistry, after reading these topics, you can get clarity. So, for understanding only for first year students, I given this explanation. Remember, there is the effect of concentration on electrolysis. If it is diluted, how electrolysis process takes place. If it is concentrated, how electrolysis process takes place, I given explanation. So here we have taken 50% H2SO4 in this process. During preparation of hydrogen peroxide, we are taking 50% sulfuric acid. 50% sulfuric acid, if you take, these reactions will not take place. These reactions will not take place. either this reaction or this reaction we can consider because it is concentrated. Okay, this information you should know. Okay, then now again coming back to this electrolysis of 50% H2S over here. See, here I am giving one rough figure diagram. I am giving here 50% H2SO4 electrolysis. For this, we should take, we should know what are the electrodes and what is the electrolyte. All these things I should know. So, what are the electrolytes here? Electrolyte is nothing but already written there. It is 50% sulfuric acid. Electrodes are nothing but here. Electrodes are nothing but platinum and also graphite we should take. Platinum and also graphite we should take. Anode is here first I am getting electrolyte. Electrolyte is 50% sulfuric acid. This is electrolyte. And here two electrodes we should take. One is anode, other one is cathode. One is anode, other one is cathode. Here anode is platinum white, cathode is graphite. Cathode is graphite. So we can arrange in this way. See here I am taking like this one container. Here we should add sulfuric acid. This is electrolyte. This is the electrolyte. In this we should keep one electrode. That is the graphite. This is the graphite electrode. This is the graphite. Graphite is nothing but carbon only. This is the graphite electrode. Graphite electrode is cathode, so it is negative charge. So here we should take one diaphragm like this, separated, and here we should take one vial, platinum vial. This is the positive charge electrode. That is anode is positive charge electrode. Here this total container is shifted to or dipped in one more big beaker like vessel, in which we should take some ice cube because whenever you are preparing hydrogen peroxide, we should take ice cold conditions. We should take ice cold conditions. Okay, here we should take ice cold conditions. These are the ice cubes to maintain 0 degrees centigrade. Otherwise, if it somewhat more temperature is taken, maybe there is a chance for decomposition of hydrogen peroxide. So that here ice cold conditions we have to use. When by using this graphite cathode and platinum anode, when electricity is passed through that, there is a dissociation takes place. Always in electrolysis process, first step is dissociation. Otherwise, ionization. So here I am writing dissociation step. In dissociation, H2SO4 dissociated now. In just now I have given explanation. If it is 50% and more, then it is you can consider it as a concentrated solution. Therefore, here it can dissociate into H plus ions and HSO4 minus ions. Take 2 moles here, 2 H plus ions, 2 HSO4 minus ions. This is the bisulfate ion. This is H plus ion. It will migrate towards the cathode and it will migrate towards the anode. So at cathode as well, at cathode the reaction is as well. Two H plus ions undergo reduction by taking 2 electrons and forms hydrogen H2 gas. Hydrogen gas is liberated at cathode. And at anode here 2 HSO4 minus ions I am taking. 2 HSO4 minus ions give rise to H2S2O8 by releasing 2 electrons, which is called as Marshall's acid. Which is called as Marshall's acid. Otherwise, peroxide disulfuric acid. We can say this is peroxide disulfuric acid. Peroxide disulfuric acid. H2S2O8. Here in redox reaction part, this compound is important. They ask what is the oxidation number of sulfur in Marshall's acid, otherwise peroxide disulfuric acid. Here because of peroxide bond, here oxidation number of sulfur will not be more than 6, so that maximum oxidation number is plus 6 only. Here also plus 6 you have to consider. Okay, let it be. That we'll discuss later about oxidation number. This is the Marshall's acid, otherwise peroxysulfuric acid. So then distillation of this H2S2O8 produces Carros acid, H2SO5. Then after again some more distillation of H2SO5 Carros acid produces hydrogen peroxide, which is our compound. So here I am writing at anode after formation of this compound, distillation. Distillation means it is nothing but heating with water. Here distillation. So here H2S2O8 when combines with water, when it is heated somewhat, delta sign I written there. So it can produce now H2SO5, H2SO5 plus H2SO4, sulfuric acid and Carros acid. So two hydrogens, here two hydrogens, four hydrogens, here two hydrogens, here also two hydrogens, two sulfurs, here one sulfur, here one sulfur. Total oxygens are 8 here, 1 here, 9. Here 5 plus 4, 9. This is sulfuric acid. This is called as Carros acid. Carros acid. Common names you have to remember. This Carros acid, otherwise peroxy monosulfuric acid, peroxy monosulfuric monosulfuric acid, peroxy monosulfuric acid is. Then this H2SO5, which is Carros acid, again distilled in the presence of small amounts of water, produces. See here, from these 5 oxygens, one oxygen combines with this H2O and forms our compound, that is H2O2. This is our compound. Plus this is converted into H2SO4 sulfuric acid. So in this way we can prepare hydrogen peroxide by electrolysis method. Electrolysis of 50% of H2SO4 gives hydrogen peroxide. Nowadays, to increase the concentration of hydrogen peroxide in this process, they may take electrolyte as ammonium sulfate, NH4 taken twice, SO4 along with H2SO4. The mixture of equimolar mixture of ammonium sulfate and sulfuric acid they are taking as electrolyte as to get more yield of hydrogen peroxide. And similarly, hydrogen deuteroxide also prepared by using this method only. Otherwise, we can take, see in textbook also they are given, this up to here it is preparation of hydrogen peroxide only, when potassium persulfate K2S2O8, potassium persulfate instead of peroxysulfuric acid, instead of the hydrogen I written potassium persulfate K2S2O8 when treated with D2O. D2O means deuterium oxide, heavy water. So we can get here KDSO4, potassium deuterosulfate, plus along with this we can get D2O2. D2O2 here D2O2. It is deuteroperoxide. Deuteroperoxide also prepared by using this heavy peroxide. Otherwise, that is hydrogen peroxide. This is heavy peroxide, deuteroperoxide we can say. This is about electrolysis of 50% of H2SO4. Then we have one more method, that is auto-oxidation of 2-ethyl anthraquinol. Auto-oxidation of 2-ethyl anthraquinol. So here I am writing next method. Next method is auto-oxidation of 2-ethyl anthraquinol. Anthracene you should know. Anthracene structure you should know. If you know the anthracene structure, we can easily expect how we can write 2-ethyl anthraquinone. Anthracene. Benzene you know. Benzene is nothing but just 6 carbons containing compound. Alternate double bonds are present inside. Naphthalene you know. Naphthalene is nothing but 2 benzene rings fused with each other. 2 benzene rings fused with each other. Anthracene is nothing but simply 3 benzene rings. 3 benzene rings when fused with each other, we can get anthracene. So first, I give some information related to this. So this method is auto-oxidation. Auto means self. Self-oxidation. Auto-oxidation or self-oxidation of 2-ethyl anthraquinol. 2-ethyl anthraquinol. This is the heading So first of all, you should know, here I am writing just information related to anthracene. Anthracene is nothing but this compound. This is benzene. If you take alternate double bonds here, benzene. Then if you write two benzene rings in this way, this is naphthalene. One more ring if you write like this is nothing but anthracene. While giving numbering as per IUPAC system, always this carbon should be taken as 1. Otherwise, this carbon is taken as 1. First carbon, then second carbon. This is third carbon, fourth carbon. Then this is fifth carbon, sixth, seventh, eighth. This is ninth, this is 10th carbon, 11th, 12th, 13, 14. Like this you can write. Total 14 carbon atoms will be there in anthracene. Second carbon contain ethyl group. So that here we can write ethyl C2H5, 2 ethyl. Anthra means this is anthracene. Quinol means here at ninth position. At ninth position and at 10th position there should be OH groups. This is 2 ethyl anthraquinol. This is 2 ethyl anthraquinol. We can say this is raw material. This is the raw material in the preparation of hydrogen peroxide during auto-oxidation of 2-ethyl anthraquinol. This is the raw material. So whenever it undergoes the oxidation, when air is bubbled through 2-ethyl anthraquinol solution, when air is bubbled through 2-ethyl anthraquinol solution, here I am not taking these numbers, just for understanding only I given these numbers. So again I am writing the same structure here. To manage the space, I am writing again here. So this is the anthracene. Here we can write bond. Here also we can write like bond. Like this. This is second position, ethyl group. Here OH is also OH. This is the 2-ethyl anthraquinol. Ol means what? Hydroxy group. OH groups are present. When it is treated with O2, oxygen, when air is bubbled through 2-ethyl anthraquinol, air contains oxygen. That means indirectly it is undergoing oxidation in the presence of air. So here this hydrogen now shifted here, this bond shifted here, this bond moved from here to here, this will come here and it eliminated like this. So that means that two hydrogens are eliminated. These two hydrogens here one, here one. These two hydrogens now combines with these two oxygens and forms hydrogen peroxide. This is our compound. Then this is released as quinone. This is released as quinone. See here, second position is as usual. At second position, ethyl group is present as usual. Here these bonds, if you observe, this bond is as usual here. Here also same thing. But here also same thing. Here this bond is shifted here by releasing of hydrogen, it becomes double bond. And whenever this bond shifted here, this double bond shifted from here to here, so that here we can write one more double bond. Then after this bond shifted here, so here one more double bond. This oxygen is hydrogen is separated, so that here only oxygen. So this is called as 2-ethyl anthraquinone. Why it is quinone? Because keto group is present. If keto group is present, we can say on. If OH group is present, we can say it is all. Quinol. But it is like cyclic process. So after completion of this step, after getting some H2O2, again 2-ethyl anthraquinol is reduced to give 2-ethyl anthraquinone by adding H2 gas in the presence of nickel catalyst. So this is the forward step, and in backward step, in cyclic process, this 2-ethyl anthraquinone which is produced is reduced in the presence of nickel catalyst as to get 2-ethyl anthraquinol. Again, 2-ethyl anthraquinol combines with air and forms hydrogen peroxide. Again, it produces quinone. Quinone is converted into quinol. Quinol is converted into quinone by giving H2O2. But here we'll get only 1% hydrogen peroxide. We'll get only 1% hydrogen peroxide. So this question, what is the raw material used in auto-oxidation of preparation method of hydrogen peroxide? Is seen many times. So raw material is the 2-ethyl anthraquinone. This is the method of preparation of hydrogen peroxide by using auto-oxidation method. Auto-oxidation method. Then these are the preparations. How many preparations I can just know? Here one is first sodium hydroxide H2SO4, barium peroxide H2SO4, sodium peroxide H2SO4, barium peroxide H2SO4, then barium peroxide along with carbon dioxide H2O, then barium peroxide phosphoric acid, then electrolysis of 50% H2SO4, then lastly auto-oxidation or self-oxidation of 2-ethyl anthraquinone. These are the different methods of preparations of hydrogen peroxide. Now we'll take properties. Properties of hydrogen peroxide. Some properties we will discuss in this session. Some more properties we will discuss in next session. So in this, hydrogen peroxide we can write in this H2O2. This is weak acid. Weak acid, so that it can produce one H plus ion and forms HO2 minus, which is called as hydroperoxide. Hydroperoxide ion. Hydroperoxide ion. And H2O2 can be produces 2 H plus ions and forms O2 minus 2. So in H2O2 there is a peroxide ion. There is a peroxide ion. Peroxide ion means O2 minus 2. Each oxygen carries minus 1 charge. O minus 1 is peroxide. Otherwise O2 minus 2. So as per MOD theory, molecular orbital theory, in first year chemical bonding here read MOD. Here O2 minus 2 contain how many electrons? One oxygen 16, one oxygen 8 electrons, two oxygens 8 plus 8 16 electrons. Along with this minus 2 means total 18 electrons are present. For 18 electrons, if you write electron configuration as per molecular orbital theory, like sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, like that, if you continue, all orbitals will take a pair of electrons, 2 electrons. Here for this 18 electrons configuration, will not get unpaired electrons, so that no unpaired electrons, no single electrons, otherwise no single electrons, no single electrons. Therefore this peroxide, hydrogen peroxide, other peroxide is diamagnetic. It is diamagnetic. Remember, this is the first thing. It is the diamagnetic, and because of this acidic nature, it is weak acid. Just now I told it is weak acid. So because of acidic nature, it can react with the bases. So whenever it reacts with the sodium hydroxide, H2O2, when reacts with sodium hydroxide, as per this reaction, it may give NaHO2. NaS. This is a sodium hydroperoxide. Sodium hydroperoxide, and releases H plus ion. And it releases H plus ion. Otherwise, NaHO2 we can write. Here hydrogen, here hydrogen. So H2O, H plus ion it releases means we can get water molecule, because one hydrogen of H2O2 combines with one OH group, so that sodium hydroperoxide and water. Similarly, if you take NaOH 2 moles and H2O2 1 mole of H2O2, so what we can write Na2O2, sodium peroxide it is. So here it can give 2 water molecules. So here 2 H plus ions are released, here 1 H plus ion is released. So that in this way we can expect its weak acidic nature, because it is reacting with sodium hydroxide. Its dissolution constant also, think Ka value is 1.55 into 10 power minus 12, very less, minus 12. So Ka value, based on Ka value we can expect acidic nature. So Ka value also very less, so that it is weak acid. And it has dipole moment. Almost its dipole moment is more than water. Water dipole moment, I think it is 1.84 D. As per experimental findings, it is 1.84 D. Here its dipole moment, it's because of its bent structure again, HOO, because of this structure. Here, because of this bent structure, unsymmetric structure, mu value is 2.01 d by units. This dipole moment. So that we can say it is polar. This polar compound, and it has acidic nature. So it can soluble in water because of polar compounds can soluble in polar solvents only. So these are some properties related to physical. They are the physical properties. Then here it can undergo, otherwise it can undergo self ionization, means otherwise decomposition. So just now we have discussed some preparations now. In that ice cold conditions we are used. If ice cold conditions are not used, what happens? If ice cold conditions are not used, then it can convert it into, if ice cold conditions are not used, it can convert it into 2H2O plus O2. 2H2O plus O2. See here oxygen number is -1. In peroxides, oxygen number is -1. Here oxygen number is -2. So from here to here, if you observe, decrease in oxygen number. Decrease in oxygen number is nothing but reduction. Similarly, from here to here, if you observe, O2, oxygen number here is 0. -1 to 0 means there is an increase in oxygen number from here to here. So that it is oxidation. So only one compound, that is hydrogen peroxide, is undergoing reduction and also oxidation. So only one element is undergoing reduction as well as oxidation, means we can say it is a disproportionation reaction. Disproportionation. Disproportionation reaction means the reaction in which only one element of the compound, if undergoes oxidation as well as reduction, we can say it is a disproportionation reaction. So here, because of this reduction, the compound which undergo reduction is called as the oxidizing agent, and the compound which undergo oxidation is called as the reducing agent. That means here it acts as H2O2 acts as per this, it acts as oxidizing agent. Oxidizing agent, and based on this reaction, it also acts as a reducing agent. It also acts as a reducing agent. Here oxidizing agent, always whenever it is acting as oxidizing agent, always water molecules are produced. In the reaction, if you observe product side, if only water molecules is observed, then we can say it is oxidation reaction. It is oxidant. If you observe at product side, O2 molecules are produced, then we can say H2O2, they are acting as a reducing agent. So this, it acts as reducing agent only in the presence of, only in the presence of, only in the presence of strong oxidizing agent. Otherwise, it acts as oxidizing agent only in the presence of strong oxidizing agents. Strong oxidizing agents than hydrogen peroxide, than H2O2. If any reactant is acting as a stronger oxidizing nature than hydrogen peroxide, then hydrogen peroxide acts as a reducing agent, like potassium permanganate. It is strong oxidizing agent, or potassium dichromate. It is also strong oxidizing agent. So if you take even ozone, it is also strong oxidizing agent than H2O2. So that in the presence of these reagents, H2O2 acts as reducing agent. Otherwise, it acts as oxidizing agent. Because of this reaction, we can expect oxidizing properties and also reducing properties. Now, we will discuss some oxidizing properties of hydrogen peroxide. Now, we will discuss some oxidizing properties of hydrogen peroxide. Many properties are there. If you write a two-step reaction, it is very easy to understand and it is very easy to remember also. But while writing in examination, if you write one step, it is enough. Last step, if you write, it is theory examination. If it is entrance point of view, means we have to understand that reaction. So for understanding, the writing two-step reaction is very important. How we have to write reactions and give. First of all, in oxidizing property or reducing property, any reaction it may be, that is experimental finding. That is experimental finding, so that we have to remember the statement related to that reaction. So after doing experiment, they got some products from some reactants. After experimental observation only, they give the reaction in textbooks. It is officially declared. After officially declared, then only they'll write, they'll give information in textbooks. So that what they are in textbooks or reference books, that we have to remember. Based on that, we can write the reaction. So here first we will take some oxidizing properties. Oxidizing properties. Oxidizing properties of hydrogen peroxide. In oxidizing properties, here first one is here it oxidizes, means H2O2 oxidizes, H2O2 oxidizes black, it is important, black PbS to white PbSO4, PbSO4. Particularly this reaction is used for the particularly lead paintings, which are when lead paintings which are exposed to air, which contain sulfide atmosphere. Then that white colored lead paint may blacken. White colored lead paint may be get black color. So to restore its original color, we have to take this oxidation reaction. See here, I'll write this reaction, two-step reaction I'm writing. This oxidizing property, so that H2O2 first decompose it to give H2O plus nascent oxygen. Nascent oxygen. This is a skeleton reaction. Now, if you take PBS, so as per this, so PBS to PBS over this, you have to remember. Without that statement, we can't write the reaction. So this PBS now combines with the nascent oxygen and forms a PbSO4. For example, a lead painting is saying. Lead painting is in white color or bright color. It is shiny color, shining. So whenever it is exposed to some air or otherwise atmosphere which contain S minus 2 or H2S, so immediately it can react with the S minus 2 and forms a PbS, which is in black color. So that that lead painting may become dull. So how we can restore its original color means by oxidation reaction of that lead painting which blackened with hydrogen peroxide. Otherwise, simply by washing with hydrogen peroxide, that lead paint becomes white or it takes its original color. So this is black one. So how many oxygens are there? 4. Here only one oxygen. So that 4 oxygens we should take. For getting 4 oxygens, we should take 4 H2O2. So 4 H2O2, H2O it can produce. So like this we can write. This is white. So if you write these two reactions, these 4 nascent oxygens, 4 nascent oxygens get cancelled. So here I am writing PbS 1 mole plus 4 H2O2 give rise to PbSO4 plus 4 H2O. So see, this is oxidizing property. In oxidizing properties, always you can remember. So at product side, along with one of the main product, water will be formed. If water if you observe, then it is oxidizing property. If you observe oxygen here, then it is reducing property. So this is the one reaction. Some more reactions are there, like it oxidizes potassium permanganate to potassium, this manganese salt, ferrous sulfate to ferric sulfate. There are many reactions. Potassium dichromate to chromic salt, then different potassium iodide to iodine. Many reactions we have. All those reactions along with some other matter like storage, how we can storage hydrogen peroxide and how we can concentrate hydrogen peroxide. What is the structure of hydrogen peroxide? We'll discuss in next session. Now I'm going to conclude this section here only. So stay home and stay safe. Thank you.